All right, so this is the back side of the Unit 10 D6 Notes on distributing with radicals. Because we flip to the back side, we need to make our list of perfect squares again. So take a minute, you can pause the video and make your list of perfect squares at the top. I know you can't see all my perfect squares, but the highest I went up to was 196 because I don't think we'll go much bigger than that. All right, so I want to do at least 2 more of these together before I have you try some on your own. So maybe we'll do the whole first row first. So let's look at number 4. So again, our first step would be, we know we need to distribute because there's a minus sign here, right? So I'm going to need to do -6 times the square root of 5. Now this one always trips people up because they want to say -6 times 5 and make it a 30 or a -30. But the issue here is this -6 is on the outside of the radical and the 5 is inside the radical. So we really can't multiply them together. Essentially, there's really a 1 in front of this. If you wanted to write in that 1 to help you, that might not be a bad idea. So you can multiply -6 and 1 to get -6, and then the square root of 5, there's nothing to multiply it by, so we just bring it down. Then you need to check and see if there's a perfect square that goes into 5. But the only ones to check are 4 and 1, and we don't really need to put the 1 in there because it would keep it the same. So 4 doesn't work, so that's it for that side. Then we're going to need to distribute again. So we're going to do -6 times, and in this case, it's -3 root 2. So when I look at this, I have to think about what are the numbers that I can multiply together. Well, in this case, the -6 and the -3 are both on the outside, so we can multiply those together. So -6 times -3 is a positive 18. There's not another radical to multiply the 2 by, so we just bring that down. And again, you need to ask yourself, can I simplify this? Simplify, simplify, simplify. Once you multiply, you always have to check if you can simplify. In this time, you can't simplify the square root of 2. So I have -6 square root of 5 plus 18 square root of 2. And then check to see, can I combine these together? Well, they're not like radicals. So that's our final answer. All right, so now let's look at number 5. I feel like number 5 is actually one you could probably try on your own, so why don't you pause the video, try it on your own, put your pencil down when you think you've gotten as far as you can go, and then watch it. So everyone try number 5. Okay, so first thing is we're going to distribute. So we should be doing 3 square root of 2 times 5 square root of 5. And again, remembering you can only multiply outside numbers by outside numbers. So 3 times 5 is 15. And then we can multiply the inside number by the inside number. So 3 times 5, again, 15, but now it's in the square root. And check to see if you can simplify this. Well, 9's the only perfect square. 9 and 4 would be the only ones that could possibly go into 15. And since neither of them do, we're done with that part. Then we're going to need to go ahead and do 3 square root of 2 times 7 square root of 8. And you're going to notice that you need to write smaller. And I left it positive because it was a plus 7 square root of 8. If it were a minus like this one, we would have multiplied by a negative. So then again, just like we did with this side, you cover it up if it helps you be able to see this easier. We're going to multiply the outside numbers together. So 3 times 7 is 21. And then we can multiply our inside numbers together. So 2 times 8 is 16. Then we try and reduce this. Well, in this case, 16 is actually one of our perfect squares. So we go ahead and we take the square root of 16, which is 4, and we bring down the 21. And now, remember, if there's no symbol, that means there's multiplication between them. And 21 times 4 is 84. Then we can go ahead, since my 84 was positive, I'll put a plus sign in front of it, and we can bring down the 15 square root of 15. Then we always have to ask ourselves, Can we combine these together? Well, this one has a square root, this one does not, so we cannot combine them. Remember, if you're going to add them together, they have to have the same exact radical in both. All right, so let's look at number 6 together. So let's take a minute and start out by first distributing the 2 root 3 to the 3. So I'm doing 2 square root of 3, and I'm multiplying that by 3. Okay, we don't worry about anything else right now, just this. So now when I look at it, I have 2 numbers that are outside of the radical, 2 and 3. So we're going to multiply 2 times 3 to get 6. There is no other number out inside the radical, so I'm just going to bring that square root of 3 down. Then I need to simplify. So, is there a perfect square that goes into 3 evenly? No, so that's as simplified as we can go. So then we're going to go ahead and we're going to multiply the next numbers together. Again, it might be helpful to cover this up and simply remind yourself that you're doing 2 radical 3, but in this case it's times negative 5 root 3 because the minus sign makes it negative. And again, we can multiply our outside numbers together, so 2 times negative 5 is negative 10. Then we also must multiply our inside numbers, so 3 times 3 is square root of 9. 9's a perfect square, so we can say the square root of 9 is 3. So we bring down the negative 10. Since there's no symbol, that means we multiply to get negative 30. Now we can uncover the other one. So what we really have here is 6 square root of 3 minus 30. Now again, I would check to see if they're like terms, which they're not because there's not a radical in the second one. So that's as far as you can go with this one. All right, at this point, I would like you to pause and try number 7 and 8 and on your own. And once you finish 7 and 8, you can play the video to check your answers. Okay, number 7 was one of the difficult ones, right? So we're going to do negative 3 times 27, but the 27 was in the square root, right? So that means I can't multiply these 2 numbers together because this one's on the outside and this one's on the inside. So I literally just have negative 3 square root of 27. You could put the 1 here to remind yourself to do 1 times negative 3 to get the negative 3, and that would be fine as well. Then I need to continue to simplify this, right? So we're going to go ahead and try to find the largest perfect square that goes into 27, which is 9. So 9 times 3 is 27. We bring the negative 3 down out front. The square root of 9 is 3. Bring down the square root of 3 and the negative 3 out front. Since there's nothing between them, we multiply. Negative 3 times 3 is negative 9 square root of 3. So now I'm finally done with just the first half of this. Now I need to move on to the second half of this one. So we're going to do negative 3 times, now be careful, this was a minus sign, so that means we're doing times negative 3 square root of 10. In this case, we actually have 2 numbers on the outside, a negative 3 and a negative 3. So we're going to multiply negative 3 times negative 3 to get a positive 9. There's no other square root symbol to multiply by, so we bring it down. And then I would ask myself, is 10 a perfect square? It is not. Are there any perfect squares that divide into 10 evenly? And there are not, so we can go ahead and just bring that down. And since it was positive, we can put that plus sign in the middle. And then we would try and combine these, but we have a radical 3 and a radical 10, which means they are not like radicals. So your final answer is negative 9 radical 3 plus 9 radical 10. All right, so number 8, starting out the same way, right? We distribute the first thing, which is 4 square root of 3 times 6 square root of 8. The outside numbers can get multiplied together, so 4 times 6 is 24. And then 3 times 8 would give me 24 as well. Now I have to try and simplify this. 24 is not a perfect square, but 4 is a perfect square that divides into it 6 times. And then we bring our 24 down out front. Now we can take the square root of 4 to get 2, bring down the square root of 6 and the 24 out front. Remember, it's multiplication between them, so then we end up with 48 square root of 6. Then we need to go ahead and look at the next one to distribute to. So now we're going to do 4 square root of 3 times positive 7 square root of 12. And we know it's positive because there's the plus sign that's in the middle. So now we can go ahead and we can multiply our outside numbers together. So 4 times 7 is 28. And then multiply our inside numbers. So 3 times 12 is square root of 36. Now we need to simplify this. 36 is a perfect square, so the square root of 36 is 6. We have a 28 out front, and we're going to multiply those together to get 168. Since the 168 is positive, it's really plus 168. I'd look to try to combine like terms, but this has a square root, and the 168 does not. So then my final answer is 48 square root of 6 plus 168. All right, I'd like you to pause the video again and try number 9 and number 10. So right now, try number 9 and number 10 on your own, and then check it with the video. All right, so first thing is we're distributing in. So we're going to do square root of 7 times 2. Now this looks funky because it's kind of backwards compared to what we normally like. But again, remember there's no number outside other than the 2, so we write the outside number down first. Or you could go ahead and put a 1 in front, right, to remind yourself that you're doing 1 times 2, which is 2. And then we bring our square root of 7 down because there's nothing to multiply it by. Then I need to try to simplify square root of 7. Well, 7 isn't a perfect square, and there's no number that goes into it evenly, so I'm done at that point. Then I need to go ahead and distribute the square root of 7 times negative 5 square root of 7. Give it a minute. The light will adjust back to normal. Okay. So in this case, negative 5 is the only number out front, so we're just going to go ahead and bring that down. You could always, again, write a coefficient of 1 if you're not seeing that, so you can do 1 times negative 5 to get negative 5. And then we need to multiply our inside numbers. So 7 times 7 would be square root of 49. 49, you can take the square root of. The square root of 49 is 7. And negative 5 times 7 would be negative 35. Then we can go ahead and bring down our original one, which is 2 radical 7. These are not like terms because this has a square root and the 35 does not. So my final answer is 2 radical 7 minus the square root of 35. All right, so let's look at number 10. So again, we're going to distribute as our first step. So we're going to do negative 8 times 2 square root of 5. Now in this case, there are 2 outside numbers here, the negative 8 and the 2. So we're going to do negative 8 times 2 first, which is negative 16. Since there's no other number on the inside, or inside the radical, we're just going to bring the square root of 5 down. Now I ask myself, is there a perfect square that goes into 5 evenly? And there's not, so we're done with that piece. Then we need to go ahead and multiply negative 8 times negative 6 square root of 20. All right, so we can go ahead and notice that there are 2 outside numbers, negative 8 and negative 6. So we're going to multiply negative 8 times negative 6, and we will get positive 48, right? And bring down the square root of 20 since there's no other number in a radical to combine it with. But again, I need to ask myself, can I simplify the square root of 20? Well, there is a perfect square that goes into 20, and it's 4, which goes into it 5 times. And then we need to bring down our 48 out front. Now we can take the square root of 4, which is 2, bring down the square root of 5 and the 48 out front. Remember that there's multiplication between them. So you end up with 96 square root of 5 here. And then we can go ahead, and since that's positive, we'll put our plus sign and bring down the negative 16 square root of 5. Again, we need to ask ourselves, are they like radicals? And in this case, they are both square root of 5. So this is a reminder from a while ago. If we are combining like radicals, so let's write this down at the bottom. To combine like radicals, you add the coefficients, which remember are those numbers in the front, but you keep the radical the same. And that's a big difference between when you're adding and when you're multiplying. So you need to remember, when you multiply everything. Everything on the outside gets multiplied. Everything on the inside gets multiplied. But when you're adding, the only thing that changes are those outside numbers. So we're going to go ahead and do negative 16 plus 96. And negative 16 plus 96 would be 80. But the radical stays the same. So 80 square root of 5 is your final answer. So make sure when you're doing these problems, if you have to combine them, that you add the coefficients, but that the radicals stay the same. If you're multiplying, multiply everything. But if you're adding, the only thing that changes are the coefficients. All right, so I'd like you to pause this video and try 11 and 12 on your own, and then come back and see it when you're done. All right, so first thing we do in number 11 is negative 4 radical 3 times 6 radical 3. So we multiply our outside numbers, which are negative 4 times 6, which would be negative 24. And then we multiply our inside numbers. It doesn't matter that they're the same. Every time we multiply everything together. So 3 times 3 gives me square root of 9. And then I can simplify square root of 9 to be 3. We bring down our negative 24 and multiply those together to get negative 72. Then we can go ahead and multiply negative 4 root 3 times negative 7 square root of 36. And I know I'm going over a little bit, so hopefully you guys had enough space. All right, so first thing I would do is multiply. Oh, look at that. I did something wrong. This was, oh no, we're okay. Sorry. So negative 4 root 3 times negative 7 square root of 36. So I would multiply negative 4 times negative 7, which is 28, and it's positive, so the negatives went away there. Then we'll do 3 times 36, which is 108. Then I need to try and simplify. Well, the biggest number that goes into 108 evenly that's a perfect square is actually 36, which is what we had started with. So 36 goes into 108 3 times. We bring down our 28 out front. The square root of 36 is 6. We bring down the square root of 3 and the 28 out front. Multiply the 28 and the 6 to get 168 square root of 3. Since it was positive, I put a plus sign in the front, and then I just bring down the negative 72. These are not like terms because this has a square root, but the 72 does not. So my final answer is negative 72 plus 168 square root of 3. Now for the last one. So we're doing negative square root of 6 times negative 3. Again, you don't see it there, but remember, there's really this negative 1 out front that you can't see. So we can go ahead and multiply negative 1 times negative 3, which would be a positive 3. There's nothing to multiply the square root of 6 by, so we bring it down. Then we think about if there's a perfect square that goes into 6, and there's not, so we're done with that part. Then we need to multiply and distribute to the last piece, so we're doing negative square root 6 times negative 5 square root of 3. Again, there's this negative 1 out front that we can't see, so now we're multiplying negative 1 times negative 5, which is a positive 5. And then we need to multiply our 6 times our 3, which would be square root of 18. Now we need to reduce that. Well, 18 has a perfect square that goes into it, 9. And 9 goes into 18 twice. We bring down the 5 out front. The square root of 9 is 3, so we have a 5 and a 3 and a square root of 2, and we multiply our 5 and 3 together to get 15 square root of 2. Since it's positive, I'm going to put a plus sign out front, and then we're going to bring down the 3 root 6. Then we have to decide if these are like terms that we can combine. Since this one has a 6 in the radical and 15 has a 2 in the radical, they're not like terms. So my final answer is just 3 radical 6 plus 15 radical 2. All right, and that concludes these notes, so you can go ahead and put them away and move on to the next item.